Hi everyone and welcome back. It's Kira Garfola with Greenville Tech's Math 155. Today we're going to cover section 1.4, which is equations. Most of you have probably worked with equations before in a previous class, but today we're going to go through several different types and some of them may be new, so make sure that you're following along and you're good to go. First, let's talk about what an equation actually is. So an equation is just an expression that contains the equal sign. So anytime you're dealing with math and you have a statement with numbers or letters or variables of other sorts, and there's an equal sign, then you're dealing with an equation. Equals equation. For example, maybe you have 3 times 5 equals 15. You don't have to have a variable or a letter. That's an equation. 4x equals 16. That's an equation. It's the equal sign that makes it an equation. Generally, we're going to be more interested in equations with variables, like this one up here, because it's not as interesting having 3 times 5 equals 15. We know that. That doesn't give us anything to solve for. It doesn't, we wouldn't really be putting a lot of effort into that. Usually, we're going to be working with equations where we need to actually find something. So what does it mean to solve an equation? When we solve an equation, we find the solution. And when we find the solution, all we're doing is finding the value of that variable or whatever unknown you want to call it that would make the unknown true, that would make the equation true. So whatever value that we need to plug in for x or a or whatever symbol we're using, that is going to be the solution when we can make our equation true. So for example, if we wanted to solve for x in 3x equals 12, then we need to find what value of x would make this true. 3 times what equals 12? Well, we can pretty easily see that x would be 4, right? Most of you can do that in your head. 3 times 4 is 12, so x must be 4. Sometimes it's not that simple. Sometimes we have to work with a series of operations to basically undo or unzip the equation, okay? We need to get x by itself to get that solution. As a side note, we're only going to be working with linear equations in this class, which means that we only have 3x equals 12 or some value of x. No x squared, no x to the third power, no other powers of x. We're only going to be working when x itself is just, it's an mx plus b situation if you've seen slope-intercept form, which we'll see later in this class if you haven't. Okay, so solving an equation. To solve an equation, we can add, we can subtract, we can multiply, we can divide any non-zero number or by any variable, because remember that's going to represent a number, without changing the equation. Okay? We can do anything we want to this equation, basically, as long as we do it on both sides. So if we add 4 somewhere, we have to add 4 on the other side. Okay? Otherwise, we'll end up with an imbalance that's no longer true. Now, to decide if we need to add, subtract, multiply, divide, etc., we need to think about opposites, okay? So earlier we learned about PEMDAS in an earlier section, right? The order of operation. Here we need to think about undoing, okay? So if we have a multiplication, we need to undo it by dividing. If we have an addition, we want to undo that by subtracting. The opposite is going to be our key here. What do we need to do to get back to x? So for example, if we want to solve x plus 6 equals 9, what do we need to do? Well, remember, we want to get this x by itself. We have this plus 6 that is preventing it from being by itself. So since we added that 6, we want to subtract that 6. So if we subtract 6 from both sides, we'll have x plus 6 minus 6 equals 9 minus 6. So this is going to leave us with x equals 3. Now, again, a lot of you will be able to do that in your head, and that's great. But we're setting up for more complicated equations as we go. So let's take some practice here. I really encourage you through all of these videos to pause for these practice screens. I'm not going to give a lot of time on the video just to save space, but always pause and work through these and make sure you can do these on your own. I assure you that your test will be similar to problems that we've worked in class. So if you can't solve these, you're going to have a bigger problem for your grade. First, let's talk about 3x equals 24. We need x by itself, and we see that it's multiplied by 3. The opposite of multiplication is division. So we're just going to divide both sides by 3, which is going to give us that x equals 8. Now, again, you can certainly use your calculator here for the math. I encourage that. Remember, you're going to have it all the time on your tests. Now we have x minus 10 equals 28. Well, to get x by itself, we see this minus 10. So we'll simply add 10 to both sides, and we'll be left with x equals, I said, plus 28. Goodness gracious. I cannot speak and write at the same time. So we're going to get x equals 38. Okay. Now we have x divided by 3 equals 50. Some people panic here. It looks a little more complicated, but it's really not any more complicated than our first one up there. We divided. We need to multiply both sides by 3. So if we multiply this by 3 and we multiply this by 3, we're going to be left with x equals 150. Now, we don't have to have pretty, beautiful numbers, right? We can have decimals, we can have fractions. Same logic applies. X plus 6.4 equals 12.5. All we need to do is subtract 6.4 on both sides. So we get x equals 6.1. Okay. And here is an even uglier one, but again, the exact same rules apply. To get x by itself, we need to do the opposite of this. Minus 3.598. Well, we'll simply take plus 3.598 on both sides. And that's going to leave us with x equals 8.807. Again, pause this, make sure you can sort these out and solve them, and you'll be good to go. Now, sometimes it's still not quite that simple. Sometimes we have to perform multiple steps to undo the equation. Take a deep breath when you're solving these, one step at a time. I also highly encourage you to show all of your work on a test, because if you mess up one of the steps, at least I can see where you were going. If you mess up the first step, obviously your answer is going to be wrong, but if the rest of it is correct, then it's a little bit easier for me to see where you went wrong, and it's easier for me to give you some substantial partial credit if you just made a little math mistake somewhere in your process. Now, when we're doing multiple steps, we have to be careful with that PEMDAS, with that order of operations. We want to isolate the variable. So often we're going to have to add and subtract first, okay, which is a little bit opposite. Remember, we're going backwards now. We want to get terms including only our variable of interest on one side, combine all the like terms, and then do whatever we need to do. A lot of times we're going to distribute terms so that we can combine those like terms. I really think that this is easier when we actually work through an example. Now, as a side note here also, there are a lot of times that there's more than one correct approach, okay? There are wrong approaches for sure, but you may have taken one side while I may take the other side. And that's totally fine. As long as you don't break any of the rules of mathematics, you'll get to the same answers. So for example here, we have 5x plus 7 equals 27. Well, we have 5x and we have plus 7. The first thing we want to do is make sure our entire left side or right side, depending on the equation, has x, and the entire other side has no x's. So to get the x terms on its own, we need to get rid of this 7, okay? So we're going to subtract this 7 from both sides. And that's going to give us 5x equals 20. Okay? Now we need to do it one more time. Now we have 5 times x equals 20. To get rid of that 5, we're going to divide off the 5. We multiplied it here, we're going to divide it. So now we're left with x equals 4. So here we had 2 steps. First, we had to subtract off that 7, then we had to divide off that 5. Now, to even further complicate things, sometimes the unknown or the variable is going to appear on both sides of the equation. In this case, you're still going to need to rearrange so that it's only on one side. You're going to combine your like terms, and then everything after that will be just like usual. It's usually going to involve subtracting or adding, multiplying, dividing an x term first to get it onto the other side, and then you'll go from there. So for example here, if we were going to walk through 8x plus 2 equals 17 plus 5x, notice that there's an x on both sides, okay? The first thing I do is subtract 5x from either side, okay? If you subtract 5x from either side, you're going to end up with 8x plus 2 minus 5x and 17 plus 5x minus 5x. If we combine like terms, so that means the x's go together and the whole numbers on each side go together, we're going to end up with 3x plus 2 equals 17. Well, now we're going to solve just like our previous example. Subtract the 2 so that we only have an x term on one side. So we're going to get 3x equals 15. And now we have 3 times x equals 15, so we just need to divide off that 3. We're going to be left here with x equals 5. Now, something that's really important here is that once you get this x equals 5, you can always go check it, okay? With these, you can always check and use your calculator. 8 times 5 plus 2 equals 17 plus 5 times 5. This is going to be 40 plus 2. And this is going to be 17 plus 25. 40 plus 2 is 42. And 17 plus 25 is 42. So we're good to go. It's a great way to check and make sure that you didn't make a mistake. Now again, good idea to pause here and get some practice as follows the handouts. And I'm going to go ahead and work. So definitely pause if you'd like to work it yourself, which I highly encourage. So first we have 250 plus 0.5x equals x. I personally would take this over to this side by subtracting 0.5x on both sides. And so we're left with 250 equals x minus 0.5x. Now, 1x minus 0.5x is just going to leave us with 0.5x, okay? We have 1 whole x minus 1/2 x. We're left with the other half of x. So this is going to say 250 equals 0.5x. And we'll divide off that 0.5, which is going to give us 500. Now again, I encourage you to plug this back in. If you have 250 plus 0.5 times 500, you are going to end up with 500. Plug that into your calculator to be sure. Now I've overwritten this a little bit. Let's see if I can erase a bit of that. There we go. Okay. So now we have 3.57 times the quantity of x minus 1.3 equals 0.045x plus 10.8. To solve this, I would certainly distribute that 3.57 first, okay? So I would multiply this times this times this to get a solid answer. So this is going to give us 3.57x minus, now be careful, remember that minus goes there. If you use your calculator, you get 4.641. And then we know that it equals 0.045x plus 10.8. Now we have whole numbers and we have x terms. We can subtract the x terms and subtract the x from one side, add the whole number from the other side, however you want to do it to get it alone. I'm going to subtract 0.045x from both sides. And so that's going to leave me with 3.525x minus 4.641 equals 10.8. Okay. Now I need to add this to both sides. And I'm left with 3.525x equals 15.441. And now if I divide everything by 3.525, that is going to give me that x equals 4.38. So divide both sides since we've multiplied. Let's practice one more. Two more, really. So now we have 0.9 equals x minus 100 over 5. First thing you're going to want to do is get rid of this 5. So to do that, multiply both sides times 5. So you're going to end up with 4.5 equals x minus 100. And now we see x is almost by itself. We just need to add 100 to both sides. So plus 100 plus 100. And that's going to give us 104.5 equals x. Okay. And lastly, 1.6 equals 350 minus a over 60. Something to keep in mind here, we've used x up until this point, but you can use whatever letter you want. If you don't like x, then use a, use b, use a star symbol. Be careful you don't use an asterisk because that's usually multiplication, but you can use whatever shape you want. Use a Greek letter. We're just talking about an unknown here. So again, similar to before, the first thing I do is get that 60 out of that denominator by multiplying both sides by 60. If we multiply 1.6 times 60, we get 96. And all we're going to be left with on this side is 350 minus a. Now, a is almost by itself here, but we need to subtract 350 from each side. And that'll give us minus 254 equals minus a. Now, we're not quite done here yet, okay? Because we have a minus here, okay? To get rid of a minus, remember that's basically saying times -1. So we can just multiply both sides by -1 or divide both sides by -1. It's going to be equivalent. And that's going to give us 254 equals a. Again, remember with any of these, you can go back and plug them in and check. Just be careful with the order of operations in your calculator. Please, please, please take a moment to pause this. Make sure you can work it. It's great to follow my work and follow along, but as you're prepping for a test, you should really be able to start from a clean piece of paper with just the problem and not look at my solution at all and make sure that you can get the same answer. That if you can practice to that point, you're practicing to mastery and you'll be good on something like a test. Now, what if we have -3 equals 50 minus y divided by 0.7? Take a minute, make sure you can solve this one. If you haven't figured out by all the practice problems, you will positively see these on your first test. First thing I'm going to do is try to get that 0.7 out of the denominator. So I'm going to multiply both sides times 0.7. I'm going to end up with -2.1 equals 50 minus y. If I subtract 50 from both sides, I'm going to get minus 52.1 equals minus y. And even if I multiply or divide by -1 on both sides, I'll end up with 52.1 equals positive y. And that's my solution right there. Please be sure that you're using your calculator to help you with this math. I would not expect you to be able to do this all in your head. And as you're going to catch me, I'm sure throughout this semester, doing math in your head is dangerous, even for somebody that's very good at it and is very experienced with it. Okay, it's easy to drop negatives. It's easy to add incorrectly or multiply incorrectly. Using your calculator will help you prevent those little math errors. Also, you want to make sure that you are showing your work on tests, again, for partial credit. If you make a math mistake and I don't see any work, then I don't know if you made a math mistake or if you just have no idea what you're doing. Something that's also worth noting is that the answers x equals 2 and 2 equals x are identical. You can put that unknown on either side. So up here, you could have 52.1 equals y, or you could write, depending on which side you solve first, y equals 52.1. Okay, those are equivalent. It's a matter of preference, and it's also a matter of sometimes you might bring x to one side and your neighbor might bring x to the other side, and that's going to decide where you're going to have it. Now, solving equations is simple enough. It's just practice, 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 right? But in the real world, a lot of times we're not going to be solving equations directly. We have to create an equation to solve, okay? We have to figure out what we're even solving for. And a lot of times these, like I said, are going to be real world applications. And along that, sometimes that means that you might have to have some subject knowledge. Maybe you need the definition of a word. Maybe you need a formula for a calculation. I mean, it could be something simple or it could be something very complex. Think about filing taxes. Think about, those are complex algorithms that they have in place. There are a lot of things that we can use, and a formula is just a formula, right? So some subject knowledge may be necessary. You're not going to have a formula sheet on your first test, but after that, you're going to have formula sheets. You won't need one on your first one. But you'll want to reference those. Very little formulas in this class have to be memorized. There are a few things that have to be memorized, but very few. And I'll make sure that we point those out as we go. So, for example, if we know that the perimeter of a square is 80, and one side has the length of x, and we want to solve for x. Well, this is going to tell us that we need to understand what perimeter is. And remember, the perimeter is the sum of all sides. And remember also here that a square has equal sides, and there are 4 of them, okay? So if we know that the perimeter of a square is 80, and we know that one side has length x, then that also means that all of our sides have to be x because it's a square, okay? So if all of our sides are x, then the perimeter, which is the sum of all 4 sides, is just going to be x plus x plus x plus x equals 80, which tells us, hey, 4x equals 80. If we divide both sides by 4, we're going to get x equals 20. So here we needed a little bit of subject knowledge. We needed to know what perimeter was, how to find it, and we needed to know what a square was. Now, these slides are really just here for your reference. They're not meant to be memorized or anything like that. I would never ask you to tell me to regurgitate all of this. But if you just want a quick reference to solving equations, remember that you're going to multiply out your parentheses first, distribute as you need to. If you have an unknown on the denominator, so at the bottom of a fraction, make sure that you multiply both sides to get rid of that. I tend to multiply both sides anyway if I have a fraction because I don't like working with fractions if I can help it. If the unknown or variable is on both sides, make sure that you move it just to one side. If you're dealing with addition, you want to get rid of it with subtraction. If you're dealing with subtraction, you get rid of it with addition. If you're multiplying, make sure that you divide. And if you are dividing, make sure that you multiply. If you're solving word problems, the first thing you need to do is make sure that you read the problem several times if it's necessary until you know what you're doing. It's hard to solve the math if you don't know what's being asked for, okay? So you've got to get the words first and then you can get the math. Assign a variable, so X, or this is where that symbol of choice comes into play, to represent that unknown quantity. Use pictures as necessary, just like I drew the perimeter there, you can draw. Write down your equation using the variable, and then solve the equation just like before. The one thing that you want to be really careful with here is that you're using the units that you're supposed to and any context that you need to. And it's always a good idea to check the answers in the words of the original problem. Okay, so let's spend the rest of this time with a little bit of practice. The first thing is that Mark has $1.55 worth of nickels. How many nickels does he have? Well, here you need to remember that a nickel is worth 5 cents. So he has $1.55 worth of these 5-cent nickels. Okay, so how many does he have? That's what we're looking for. This is going to be X. Okay, so we know that 5 cents times however many he has is going to be $1.55. We've multiplied by 5 cents, so we need to divide both sides by 5 cents. And that is going to give us that X equals 31. So he has 31 nickels. Now we can look at another one that's similar but different. Mona has twice as much money as Roger, and together they have $7.50. How much does each person have? For these, I always like to determine what I'm comparing. Here, I'm comparing what Roger has, okay? Roger is the basis of comparison. So we know that Roger here has to be X. We also know that Mona plus Roger is 750. Okay, so it's 7.5. Mona is twice as much as X, so that's going to be 2 times X. So Mona is 2 times X, Roger is 1X, and together they make 750. So 2X plus 1X is 3X. And now we just solve like a normal equation. Not divided by X, it's divided by 3. Let me fix that real quick. So remember, we have X equals 750 divided by 3. We use our calculator, we'll see that X is going to be 2.5. Now this is where units come into play. We're talking about money. So that's going to mean $2.50 is X. Now remember, that's Roger, right? So Roger has 250 and Mona has twice as much. Which is going to be $5. And sure enough, $5 plus 250 is going to be 750. Okay, so something similar. I'd highly encourage you to pause here, make sure you can solve this, and then check your answer. The value of Mike's house is $20,000 less than David's house. If the value of Mike's house is $150,000, we want to know how much David's house is. Okay, so we know that we are comparing David's house. So let's let David's house be X. We know that Mike's house is $20,000 less than that. So we know that Mike's house is X, but minus $20,000. Okay, because we know that $20,000 less. Be careful here that you don't do 20,000 minus X. Okay, it's 20,000 less than X. So if I tell you, hey, you made $3 less than $10, then you made 7, right? The less is after. So whatever David's house was is this X, and then we have to subtract $20,000 to get the value of Mike's. Now we have this other piece of information that says, hey, Mike's house is $150,000, and we want to find David's house. So we know that Mike's house being 150,000 means that X minus that 20,000 is going to be that 150,000. Okay. So now we just solve the equation as usual. Add 20,000 to both sides. And we are going to get that X equals 170,000. So David's house, which is X, is going to be $170,000. And now you can go back and look at the original. Mike's house is $20,000 less. So $20,000 less than David's would be 170 minus 20, so 150. And then sure enough, it says, hey, Mike's house is 150. And we have checked our answer there. Now, what if Gary wishes to cut a 10-foot board into 2 pieces so that one piece is 4 feet longer than the other? How long should each piece be? Some people might want to draw a picture here. Now, obviously, this isn't going to be to scale. But you know that you have a longer piece and a shorter piece. And you know that the whole thing is 10 feet. Okay? Than the other is our X. Okay? 4 feet longer than the other. So one of them is X, and the other one is 4 feet longer than that. And we know that we have 2 pieces, right? We have one piece that's X, we have one piece that's X plus 4, and also that when we add them together, they have to be 10 feet. Because the whole board is 10 feet. We don't have any less, we don't have any more. So we know that X plus 4 is going to be 10. If we combine these X's, we know that 2X plus 4 is 10. Subtract 4 on both sides to get 2X equals 6, which is going to tell us that X equals 3. So our pieces are 3 feet and 3 plus 4, which is 7 feet. And again, go back and check. You have a 10-foot board, so 3 plus 7 is in fact 10 feet, so good. And then you have one that's 4 feet longer than the other. And sure enough, 7 feet's 4 feet longer than 3. So we're good to go. Now we have the sum of 2 consecutive even integers is 146. And we want to find the 2 integers. From a glance, this might be confusing, but it's a lot simpler than it needs to be. Okay, than it might look. The sum of 2 consecutive even integers. Well, remember even 2, 4, 6. This is just saying, hey, a number like 2 plus the next one will be 4 equals something. Okay. So we know that one number, so some even number that we make up X, plus the next even number has to be 146. Well, if x is our starting point, then the next even one has to be x plus 2. The two of them added together have to be 146. So we get 2x plus 2 equals 146, which is going to tell us that 2x is 144, which is going to tell us that x is going to be 72. So the two numbers are 72 and 74. And again, you can check this. Is 72 plus 74 146? It is indeed. So we're good to go. These are easy to check. Okay, now, some of you, a lot of my students, are usually confused by how I choose x and how I choose x plus 2. The important thing here is to think about any numbers, right? 2, 4, 6, 8, 10, all the way up. You can say up to, 102, 104, 106, whatever. Okay. The key difference here is that any two consecutive numbers, if I choose 4 and 6, if I choose 104 and 106, if I choose 8 and 10, any of these, there is a plus 2 gap here. That is the key here. So for any even number here of x, to get to the next consecutive even number, all I do is add 2 to that number. So I take the original number and I add 2. That's why we have x and x plus 2. The same exact thing, by the way, is true if I had asked you about consecutive odd numbers. The only thing is it wouldn't be able to equal 146. So different numbers, that's why this one's even. So if you were to see on a test or something like that, the sum of two consecutive odd numbers, you do the exact same thing. X plus 2 equals whatever that is, and you solve just like this. It'll still be plus 2 because odd numbers are still two numbers apart. Okay, let's think about one more example. In 7 years, Bobby will be 59 years old. How old is he now? Now, a lot of you can do this in your head just intuitively, and that's great. Because if you do it in your head and then you set it up algebraically, you are learning how to do it algebraically with intuitive problems. So when you get harder problems that you can't quite think through in your head, you still know how to do it. So we know that Bobby will be 59 years old in 7 years from now. So how old is he now? Let's let that be x. And we know that what he is today plus 7 years, he's going to be 59. Okay, that's all we're doing when we set these up. Okay, what he is today, 7 years from now, 59. If we subtract 7 from both sides, we get that x equals 52. So he is 52 years old today. You would do the exact same thing for less intuitive problems. Okay, how old he is that you're looking for is x, and you know that 7 years from x, he'll be 59. Okay, any questions that you have? Remember that you have extra problems in your text. You have lots, actually. There's practice problems throughout the lessons. There's examples with worked solutions. And then at the end of each section, there is, practice problems, and the solutions are behind the practice problems. Lots of places to get practice, okay? There's also the additional lecture notes that have some videos from another instructor. So that's a good place to look. And you can also always email me, right? I highly encourage you to try to find the answer on your own using these two options. Because generally speaking, if you put in the effort to learn it, you do typically retain it better. However, if you're still confused, you can always reach out to me by email. Now, also, keep in mind that you're going to have assignment 2 due soon. Look at your course content to see which sections are covered by, or your course calendar, excuse me, the course schedule, to see which sections are covered in assignment 2 and when it is due. But know that that is going to be upon you soon. Thanks for listening, and I will see you next time.